Hadoop has some interesting design principles which have defined the shape of the project and why it may look a little different than some things we're used to seeing. As I said previously, a key aspect of Hadoop is moving the computation to the data to minimize the amount of data that has to flow around the cluster on and off hard disk drives. Another important aspect of Hadoop is hardware is going to fail. Let's manage it from the beginning so that it's not an afterthought and it's part of the design of Hadoop, and the fact that it will handle hardware failure as applications run and not bring the whole system or even a single application down should you have a hardware failure. Now obviously there's some limits to that, but indeed Hadoop has been designed to be very robust. In a similar way, Hadoop tries to hide the execution details from the user. The MapReduce process actually does this in a very interesting way, and we'll cover this a little bit more later. But the essential idea is to move the user closer to their application, and in the MapReduce parlance, that means they focus on the map step and the reduce step, and not all the data flow and transfer and messaging that has to happen to get these steps to work together. So obviously it can be a little bit more involved than that, but that's basically the general idea. Everything else just pretty much happens in the background, and the user sets up their MapReduce process and results come out. The other design principle that's very important is using streaming data analysis, and we'll see the design of the Hadoop file system is based on this idea and has some very different aspects to it than a normal file system. And streaming basically just means we're going to move lots of data very fast into and out of different places in our Hadoop cluster. We're not going to be really concerned about random access. We're going to take big blocks and just move them through and different processes and systems in a Hadoop cluster. And finally, because of the functional nature of the MapReduce process, we're going to use a simple file system coherency model. And that may seem a little strange at first to most people. However, in light of how Hadoop is designed in the MapReduce process, it makes perfect sense. And there will be some restrictions on what we can do with files, but these, once we see the advantages we get by treating files in this way, we'll certainly take them as a good thing. Now it's also important to be clear what Hadoop is not. It is not a replacement for SQL, and it's not always fast and always efficient. And it's not necessarily good for a quick ad hoc querying. So we're not talking about taking all your SQL files and converting them to Hadoop and making them run faster or maybe even slower. And indeed, Hadoop may not be the best design for that in any case. So I wanted to be clear about that, and that Hadoop is primarily designed for big unstructured data files.